Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our second lesson on a given Form 4 mathematics topic called differentiation. So we are looking at our fourth example, which reads that find the gradient of y is equals to x squared into x squared plus 4x plus 4 divided by x plus 2 at the point -2, 7. So for us to find the gradient, we need to have the gradient function, and of course to get the gradient function we shall need to differentiate the given equation. So we know that we can only differentiate a linear equation. Therefore the first step is to convert this equation into a linear equation. So the easiest way of doing that is to find the factors of this particular part so that we see if there are any factors that can cancel with our denominator. So within the bracket we are given a quadratic expression which is x squared plus 4x then plus 4. So clearly this is a quadratic expression in the form ax squared then of course plus bx plus c. So whenever you are given a variable x squared, it means that the coefficient was 1. So clearly the value of a was 1, the value of b was +4, and the value of c was a +4. So to factorize, we need to find the product, which is usually equal to the value of a multiplied by c, which will be equal to a. Clearly a is 1, then multiplied by the value of c is a +4. So 1 by 4, I'll get +4. Then the value of the sum will be given by the value of b, which clearly will be equal to +4. So to get the factors, we usually factorize the product. So by 2, this will be 2, then by 2 that will be 1. So the factors, we have 2 times 1, which is 2, and of course 2. So clearly the product 2 times 2 will get +4. The sum 2 plus 2 will still get +4. Therefore it means that our numbers are 2 and 2. From there we copy the original equation which clearly was x squared then of course plus 4x then plus 4. Then we substitute the value of b. So that means where I'm having the value of b, clearly the value of b was +4. So where I'm having the value of b, that is the +4, I'm going to substitute with my factors. So this will be equal to x squared then of course plus, where I'm having b, I'll substitute with my numbers which are 2 and 2. So 2 plus 2. Then of course I close the bracket. We had an x then plus 4. On opening the bracket, I'm gonna have x squared then plus 2 times x, I'll have 2x then plus 2 times x, I'll still get 2x then plus 4. So clearly the common factor between the first two terms is x. So I'll factor it out. So I'll have x into x squared over x, I'll get x, then plus 2x over x, I'll get 2. Then here I'll factor out +2, that is in the last two factors. 2x over 2, I'll get x, then plus 4 divided by 2, I'll get 2. So clearly I'll pick this value and this value here to form the first bracket. So I'll have x plus 2. Then I pick one of the brackets, which is simply x plus 2. So that means if I rewrite my numerator, I'm gonna have the following. So my numerator, the equation was y is equals to x squared then into x squared plus 4x then plus 4. Then the whole of it was divided by x plus 2. So that means my y will be equal to x squared. Now this particular equation, that is the x squared plus 4x plus 4, has simplified to x plus 2, x plus 2. So that means I'd have x squared into x plus 2 multiplied by x plus 2. Then the whole of it was divided by x plus 2. So on dividing with x plus 2, clearly we'll have some common factors. X plus 2 will cancel with x plus 2. Therefore y will be equal to x squared into x plus 2. On opening my bracket, I'll have y being equal to x squared times x, I'll get x cubed. Then x squared times 2, I'll get a +2x squared. Therefore the aim of the question was to find the gradient. So to compute the gradient function, we'll find the dy dx, which will be equal to, if I differentiate this part, of course the 3 will pre-multiply the x power 3, then of course I subtract 1 from the power, then the 2 will pre-multiply the coefficient of x, so I'll have positive 2 multiplied by 2, x to the power of 2, then of course I subtract 1 from the power. So this will be equal to 3x, 3 minus 1, of course I'll get 2, then plus 2 by 2, I'll get positive 4, then x to the power of 2 minus 1, I'll get the power of 1. Therefore, to find the specific gradient, it means that I'm remaining with my gradient function as dy dx being equal to, so this is 3x squared, then of course 3x squared, then plus 4x. X power 1 is the same as x. Therefore, dy dx through the point negative, through the point negative 2 7. Clearly, the value of x will be 2, then the value of y will be 7. So through this particular point, I'm going to have 3, where I have x, I'm going to substitute the value of x, which is negative 2. So I'll have 3 into negative 2 squared, then plus 4 into my x is still negative 2. Therefore, dy dx will be equal to 3, negative 2 squared, I'll get positive 4, then plus 4, then of course multiplied by negative 2. So this will be 3 by 4, I'll get 12, 4 by negative 2, I'll get negative 8. Then of course 12 minus 8, I'll get a positive 4. Therefore, the gradient through the point negative 2, 7 will be equal to positive 4. Therefore, that was the gradient of this particular curve through the point negative 2, then 4. We check example 5, which reads that find the gradient of the curve y is equals to x cubed minus x over x plus 1 at the point 3, 1. So clearly, to differentiate, we need to have a linear equation. So to find the linear equation, I'm going to factor out x in the numerator. So I'm going to have y being equal to x, then of course into, this will be x squared, then of course minus 1. So clearly, this is what we call a difference of two squares, because we can rewrite it. So this will be equal to x into x squared minus 1. Then of course, this will be equal to then divided by x plus 1. So I can rewrite this as y is equals to x, then into x squared, then minus 1. 1 is the same as saying 1 squared, then divided by x plus 1. I'm writing it as 1 squared because I want to introduce the property of the difference of two squares. So considering this part, that is x squared minus 1 squared, these are difference of two squares, which is a squared minus b squared. Remember, this one is always equal to a plus b, then multiplied by a minus b. So clearly, on direct comparison, my a will be x. So this one will be equal to x, then of course plus 1, then multiplied by x minus 1. I've applied the property of the difference of two squares. So on rewriting, I'm going to get y being equal to x. So I am having x squared minus 1 squared. I'll replace it with x plus 1, x minus 1. So I'll have x into x plus 1 multiplied by x minus 1. Then the whole equation was divided by x plus 1. So over x plus 1. So clearly, there are some common factors. X plus 1 will cancel out. So that means my y will remain to be equal to x into x minus 1. So which is equal to, y is equals to x times x, I'll get x squared. Then minus x times 1, I'll get x. So the equation is now in linear form. So we can easily get the gradient function. So from y is equals to x squared minus x, the gradient function dy dx will be equal to, On differentiating, this will pre-multiply with the coefficient, so this will be 2x to the power of 2, then I subtract 1 from the power. Of course, this one means it was power 1, so this will be negative 1 x to the power of 1 minus 1, which means that my dy dx will be equal to 2x to the power of 1. That is 2 minus 1, I'll get 1, then minus 1 x to the power of 0. Remember, a power 0, the answer is always 1. So it means that this one will reduce to be 1. Therefore, my dy dx, the gradient function, will be equal to 2x. Then, of course, minus negative 1 times 1, I'll still have negative 1. So at the point 3, 1, our gradient will be equal to, so dy dx through the point 3, 1, clearly the value of x will be 3, then the value of y will be 1. So this will be equal to 2 into my x is 3, then minus 1. So that means our gradient will be given by the following. So the gradient dy dx will be equal to 2 times 3, I'll get 6, then minus 1. Therefore, this will be equal to 5. Therefore, our gradient, the gradient through the point 3, 1 will be equal to 5. We check our sixth example, which reads that at what point is the gradient of y is equals to x squared plus 3x plus 2 equal to 9. So because we are already given the gradient, we first of all get the gradient function. So the equation was y is equals to x squared, then plus 3x plus 2. Therefore, the gradient function dy dx will be equal to, I differentiate these. So this one will be 2x to the power of 2 minus 1. And then, of course, plus. This one means it was power 1. So I pre-multiply. This will be 3 multiplied by 1, x to the power of 1 minus 1. Then if we differentiate this, it means it was to the x power of 0. Because this is 1, 2 times 1, you'll still get 2. So on pre-multiplying with the coefficient, I'll have positive 2 multiplied by 0, then x power 0 minus 1. So of course, I'm told that the gradient is equal to 9. So this one should be equated to 9. Therefore, my dy dx will be equal to, this will be 2x to the power of 1, that is 2 minus 1, then plus 3 times 1, I'll still get 3x power 0. Then, of course, whenever you multiply anything by 0, the final answer will be 0. So this one is equals to 9. So dy dx will be equal to 2x. X power 1 is the same as saying x. Then plus, this one will give us 1. X power 0 is 1. 3 times 1, I'm going to get 3, which is equals to 9. So to get the value of x, I'll consider this part of the equation only. So I'm having 2x plus 3 being equal to 9. So clearly 2x will be equal to 9 minus 3. Therefore, 2x will be equal to 9 minus 3. I'm going to get 6 divided by 2 divided by 2. So clearly the value of x will be equal to 6 over 2. That will give me 3. So the value of x is equals to 3. But the question does not want the value of x. The question wants a point. A point is always made by the values of x and y. So we have the value of x. So we need to get the value of y. To get the value of y, I'll substitute in my original equation, which was y is equals to x squared, then plus 3x plus 2. So the value of y when x is equals to 3 will be equal to, so this will be equal to into bracket 3 squared, then plus 3 into 3, then plus 2. So my y will be equal to y is equals to 3 squared. Of course, I'll get 9, then plus 3 by 3, I'll still get 9, then plus 2. So this will be equal to 9 plus 9, that is 18 plus 2. Therefore, my y will be equal to positive 20. Therefore, the point, a point is always given by x, comma y. Therefore, my point will be equal to, the value of x was 3. So this will be 3, comma, my value of y is 20. Therefore, through the point 320, the gradient of this particular curve will be equal to 9. Then we look at example 7, which reads that find the gradient of y is equals to x power 4 minus 2x cubed plus 3x power 2 plus 2x minus 5 over x cubed at the point x is equals to 1. So to find the gradient, we need to differentiate. So to differentiate, we can only differentiate a linear equation. So I'm going to rewrite this one as a y is equals to, I'll divide everything by the denominator. So this is x power 4. Then of course divided by x power 3, then minus 2x cubed, which is being divided by x to the power of 3, then plus 3x squared divided by x power 3, then plus 2x, then divided by x power 3, then minus 5 divided by x to the power of 3. So this will be y is equals to, we need to apply the laws of indices. We know that a power m divided by a power n is the same as saying a power m minus n. So clearly the first part, because the bases are the same, which is x, so this will be x to the power of, we subtract the powers. So this will be 4 minus 3, then minus 2x. So this 2 will give me x to the power of 3. Then of course minus 3, then plus 3 x, this 2 will give me 2 minus 3, then plus 2. Of course this one means it was the power of 1, so this will be x into 1 minus 3, then minus 5 divided by x to the power of 3. So on simplification, we're gonna have y being equal to, this will be x to the power of 4 minus 3. Of course, I'll get 1. Then minus 2, x to the power of, this will be 0, 3 minus 3. Then plus 3x to the power of, this will be negative 1. That is 2 minus 3. Then plus 2x to the power of, this will be 1 minus 3. Of course, I'll get a negative 2. Then, of course, minus 5. Remember, this can still be written as multiplied by x power negative 3. Remember, from the laws of indices, if you have 1 over, that is 1 over a power n, is the same as saying a power negative n, which is basically a power, that is 1 divided by a power n, will give us a to the power of negative n. So what I've done here, I've taken, this is like negative 5 divided by x power 3. This will be negative 5 x to the power of, so the sign of the power will change to negative 3. So that is why I'm having a negative here. That is, whenever you divide, is the same as saying multiplying, but the power changes to negative. If the power was positive, it changes to negative. If the power was also negative, it will change to positive. For example, 1 over a power negative n is the same as saying a power at the positive n. So these are simply basically the laws of indices. So clearly I'm having a y being equal to x power 1 is the same as saying x, then of course minus 2, x power 0 is 1, so negative 2 times 1, I'll get 1. So this is the same as saying multiplying by 1, then plus 3, x power negative 1, then plus 2, x power negative 2, minus 5, x power negative 3. So this will be y is equals to, so this will be x, then of course minus 2, then of course plus 3 to the power of, that is x to the power of negative 1, then of course plus 2 x to the power of negative 2, then minus 5 x power negative 3. Now with this we can easily differentiate so that we can get the gradient function. Therefore our dy dx will be equal to, if I differentiate these, of course this will pre-multiply, so this will be 1 x power 1, then I subtract 1 from the power. The derivative of a constant is always 0 because this is x power 0, so this will be negative 2 multiplied by 0, then x power 0 minus 1, then of course this will be plus 3 multiplied by negative 1, x power negative 1 minus 1, then this will be positive 2, then of course multiplied by negative 2, x power negative 2 minus 1. Then of course, this will pre-multiply here. So I'll have negative 5 multiplied by negative 3, then x power negative 3 minus 1. So on simplification, we'll end up with 1 x power 0. Then of course, the whole of this will disintegrate to 0 because 0 multiplied by a number is 0. That is why we said the derivative of a constant is always 0. Then minus 3 by negative 1, I'll get minus 3 x power negative 2. Then of course, this will be minus 4, this part here, minus 4 x power minus 3. Then negative negative will give me positive 15 x to the power of negative 4. So that means in the end, I'm gonna remain with the following. So my dy dx will be equal to, so here of course I'm remaining with the 1 because x power 0 is 1. 1 times 1, I'll just get 1. Then of course here I'm going to have 0. There's no need of writing 0, but I can just have it here. Then this part will give me negative 3 x power negative 2. So this is negative 3 x power negative 2. This part here will give me negative 4 x to the power of negative 3. Then of course I'll have minus 5. That is minus 15. This was minus 15. No, negative gave me a positive. So this is positive 15. So this is positive 15 x to the power of negative 4, which essentially will give me 1 minus 3 x power negative 2, then minus 4 x power negative 3, then plus 15 x power negative 4. So to differentiate so that we can get the gradient function, this will be equal to, so my dy dx, yeah, I already have the gradient function. So we just need to apply it at the point x is equals to 1. So my dy dx through the point x is equals to 1 will be given by, so this will be, this can be written as 1 minus 3, then into, this will be 1 power negative 2, then minus 4 into 1 power negative 3, then plus 15, then of course 1 power negative 4. Remember, this can still be written as 1 power negative 2, I'll just get 1, so this will be 3, then minus 4, 1 power negative 3, I'll just get 1, then plus 15, 1 power negative 4, I'll still get 1. That is a 1 to the power of anything will just remain to be a 1. So this will be equal to, this is, so I'll have 1 minus 3 minus 4, then plus 15. So of course this will give me 1. This 2 will give me negative 7, then plus 15, which will be equal to, this will be negative 6 plus 15, which clearly will give me 9. Therefore, it means that the gradient, that is dy dx, was equal to 9. Therefore, the gradient when x is equals to 1 will be equal to positive 9. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you're new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.